All right, the distance learning experience continues. We're going to look at 12.8 today, which is more graphing trig functions, but now we're going to move our graphs left and right, which is called a phase shift, and up and down, which is referred to as our vertical shift. We've done this before with our graphs, so it's nothing new as far as things go. It's just going to look a little different because now we're graphing waves instead of lines or parabolas or absolute values. But everything's going to kind of behave the same way as before. So, first things first, phase shifts. If you guys are looking here, sometimes these are referred to as our horizontal shift. So I'll write that in there, horizontal shift. All right, and this is basically moving our graphs left and right. All right, when we were graphing sine waves, I actually never told you the acronym, which is sometimes helpful. For sine graphs, we have a 0 is where we start. We go high, we come back to 0, we go low, and then we go back to 0, or solo. So if you've heard some of your friends in Brostrom's class, they may have already used this or said that to you, and you're probably like, what the heck is that? That's the acronym. So for our sine graphs, we like to refer to this as solo. So sine graphs, 0 high, 0 low, 0. Stupid gimmick, but sometimes it works if we're a little confused about graphing. All right. Cosine isn't pictured here, but I will show you that acronym later on our first example. Okay. But keep in mind, as we look at this, we have our general function up here. We still have our a value, we still have our b value, but now we have this h value. H should look very familiar to you guys. That's how we shift our graphs left and right. And if you notice, in this case, we're just shifting our graph left and right. So our sine waves today don't necessarily have to start at 0, 0. So the blue is our traditional sine wave, and then the red is our graph shifted h units. Okay. Just like before, if h is positive, we're moving to the right. H is negative, we're moving to the left. So it's kind of the opposite of what you see in your equation. But we're going to dive right into things here. So graphing on this problem here, the one thing I encourage you to do first of all is factor out b if it's in your problem. So if I take out 2 from each of those, we're going to have 2 cosine 2 parenthesis x minus pi halves. The reason we do that is then we can identify our a, our b, and our h very easily. So as we go through graphing, we're always going to identify key characteristics of our graph, such as our amplitude. In this case, we know our amplitude is 2, corresponds to our a value. Just like before, periods with sine and cosine are always determined by 2 pi over b. In this case, b is 2. 2 pi over 2 is 2. So my period is 2. Or sorry, not 2. What am I doing? Our period is pi. The 2's cancel. All right, so if I go to my graph, I'm going to go out pi, and then just like before, we're going to divide our graph into fourths. So we have pi halves, we have pi fourths, which would make this 3 pi fourths. All right. Simple thing to set up. If you want to include a table as well, you can include a table. We're going to start ours at 0. We go out to pi, and then just like before, if we take half of our period, that's pi halves. If we take a quarter of our period, it's pi quarters, and 3 pi quarters. Just the same way we sectioned off our graph. Okay, so we're essentially doing everything the same as we did in 12.7. It's just we're adding this next part. All right, and this next part is our phase shift, or sometimes called our horizontal shift. In this case, you can see our graph is shifting right pi halves. All right. Graph is shifting right pi halves. We haven't talked about vertical shift, you guys, but our vertical shift is going to be this k value off to the side. We'll talk about it on our next example. In this case, there is no vertical shift. All right. Then we're just going to do everything like we did before. So we're just going to take our x values. We're going to plug them into our equation, solve using the unit circle. All right. Easiest thing to do on these ones is plug your information into the original equation. I typically find is slightly easier. So if I plug in a 0 for x, 2 times 0 is 0. 0 minus pi is negative pi. So if we think about our unit circle, negative pi is actually way over there. Okay, the cosine value there is negative 1. Negative 1 times our 2, which is out front, is negative 2. Then we can plug in pi fourths. Again, we're plugging in pi fourths for x. Pi fourths times 2 is pi halves. Pi halves minus pi. So if you think about it, pi halves minus pi is going to be negative pi halves. So we're down here at 270 or 3 pi halves. On the unit circle, our cosine value is 0. 0 times 2 is 0. All right. As we probably remember our pattern, you can continue it or you can keep plugging in values, but I know the next time my cosine value is going to be positive 1. 1 times 2 is 2. And then we can finish off our pattern, or we can continue plugging those in, whatever's easiest for you. Then we plot our points. So we have 0, negative 2, pi fourths 0, pi halves 2, 3 pi fourths 0, and at pi, we're back at negative 2. Okay, so acronym time. So sine was solo, cosine is actually cholo. Okay, and if we think about this, it still makes sense because our graph shifted right pi halves. And with cosine, if you remember, cosine always starts at a peak. So high, 0, low, 0, high. If our graph were to continue, cholo. And if you notice, where did the peak start? Well, surprisingly enough, it corresponded exactly to the place or location of our horizontal shift. Awesome. Easy peasy, hopefully. Again, just building on those concepts from yesterday. But that should kind of be your work. We're going to ask you to identify those 4 things each time and construct 1 or 2 cycles of your graph. We're never going to have to graph more than that. Okay? So that's how you graph a sine and cosine. We're going to go into another example here with a vertical shift. All right. Mentioned it a little bit before, but same idea. So we're going to go through and identify all this information. So our amplitude is 1/2, corresponds to our A value. Our period, keep in mind, it's a sine graph, so we have 2 pi over b, so our period is just 2 pi. Horizontal or phase shift, if you notice, nothing's happening to theta itself, so there is no phase shift or horizontal shift, but we do have this negative 2 off to the side, so after we multiply by 1/2, we're subtracting 2 from our values, which means our graph is going to move down 2. Now, we can do everything just like we did before. So we have 2 pi, we have pi, we have pi halves, and we have 3 pi halves. Notice our graph shifted down 2. So actually what I'm going to do is I'm going to put what's called a midline in here at y equals negative 2. And that's going to help me kind of keep my graph centered as we go through things. All right. Then we can just start plugging in values. All right. So if I'm starting my graph at 0, plug in a 0 for theta. Sine at 0 is 0. 0 times a half is 0 minus 2. So there we go. Sine graph is at 0, negative 2. When I plug in pi halves, I'm rotating up on my unit circle. Pi halves is 1, or the sine of pi halves is 1. 1 times a half is 1/2 minus 2 is negative 1.5. And then, like we said, you can keep plugging in values. Pi, sine's going to be 0. 0 minus 2 is negative 2. 3 pi halves, your sine value is negative 1. So this is going to be negative 5 halves. And then we're back at 0. So again, as you get the hang of it, everything's the exact same. We start our graph at 0. We go over to however far our period is. We cut it into fourths to hit those peak key values on our wave. And then we just plug those values in for theta to figure out our y coordinate. Okay. If you wanted to, you don't even need to do the graph, but we could just do the same way with a table. We know that we start at 0, go out to 2 pi. That's going to graph one cycle. Go to pi, pi halves, and 3 pi halves. And then we just plug those values in to get our wave. All right. As we do this, if you remember before, the acronym I had mentioned before with sine graphs was sine graphs 0, high, 0, low, 0. So hollow. And if you notice, there was no phase shift, so our graph did start again at 0 in the middle, and then we went 0 high, 0 low, 0. So hollow, 0 high, 0 low, 0. So that's how we graph a vertical shift. The last and most complicated, but really isn't too challenging, is our tangent graphs. And just like before, tangent graphs seem to be a struggle for some. So there's a few things we want to do as we begin graphing. Just like before, we want to figure out, or factor out, not figure out, but factor out an EB value. So I'm taking out 4 from each of those. So I have x minus pi fourths plus 1. This is going to help you isolate your A, your B, your H, and your K. So then when you go through this information, we figure out our amplitude. As you remember before, there are no amplitudes, okay, with tangent graphs, so we don't have to worry about that. Period. With tangents, always pi over b, which in this case is 4, so my period's pi fourths. Phase shift or horizontal shift, whatever you want to refer to it as. We're moving right, pi fourths. And then our vertical shift, we are moving up 1. Once we take care of all of those, the next thing that you want to do with your tangent graphs is figure out where your asymptotes actually lie. And if you remember before, we take our period and we split it in half. So our asymptotes would normally be at positive pi eighths and negative pi eighths. But remember, there's a phase shift, okay? So we're taking our graph and we're shifting everything, including the asymptotes, right pi fourths. So we just figured out our asymptotes should be at pi eighths and negative pi eighths. But if I'm moving right pi fourths, they're actually going to be at negative pi eighths, or negative pi eighths plus pi fourths is positive pi eighths, sorry. And then positive pi eighths plus pi fourths is going to be 3 pi eighths. So that's where my asymptotes occur. Again, we do everything the same. It's just once we get where asymptotes are, we need to account for that shift. So at this point, we can go right to our graph. I'm going to put an asymptote in at pi eighths. Oops. And then we have that. 1 pi eighths, 2 pi eighths. Trying to keep them as even as possible. 3 pi eighths. And if you notice, what is right in the middle of 1/8 and 3/8? 2/8, which is a fourth. And oh my gosh, look at that shift. It's right pi fourths. Remember, with tangent graphs, we normally were centered at 0. So it would make sense that our graph is now centered at pi fourths since we shifted to the right pi fourths. Then we do everything the same as before. So we figure out those halfway points. If we can think about this more in general, this is going to wind up being 3 pi over 16. So 2/8 and 3/8. If we divide each of those into halves, we're going to be in 16ths, which would mean this is going to be 5 pi over 16, which makes sense. 2/16, 3/16, 4/16, 5/16, 6/16. So the graph works out. If you struggle with fractions, that's obviously going to be a more challenging part of the day. But then we can just go about our business like normal. So if I'm making my table and I'm thinking about it, instead of having 0 in the middle, I'm going to have pi fourths in the middle. When I go back to my equation and plug in pi fourths, I'm going to plug it in for that x value right there. So pi fourths times 4 is pi. Pi minus pi is 0. If I'm thinking about a tangent graph, the tangent at 0 is 0. 0 times 3 is 0 plus 1 is 1. So our graph shifted up 1. All right. And if you know the pattern with tangent graphs, you guys, this next part should be quite easy, but we plug in our halfway points to the equation. If you notice, our a value on our graph is positive, so our tangent graph should actually be increasing constantly. So down to the left and up to the right. But remember, we have the a value of 3. So when I plug in 5 pi over 16 to my equation, 5 pi over 16 times 4 is 20 pi over 16 minus pi. It's going to be pi fourths. So I'm up at pi fourths. The tangent at pi fourths on the unit circle is 1. 1 times 3 is 3, plus 1 is 4. So if you are filling out your table, you're going to be up at 4 here. 1, 2, 3, 4. And then pi fourths was at 1. And if you could think about it, 3 pi 16ths is going to be down at negative 2. So then we can plot a tangent graph from there. Again, very similar to before. The only change was we had to take into account any phase shift when we graphed. So that's kind of the big picture of things. Figure out those key characteristics. Then take your period divided in half and account for any phase shift. Then figure out your halfway points, plug them into the formula, and use your unit circle to calculate those points. Again, the values in your table should work out very nicely. We're not picking things that are going to be super complex as far as things go. All right, so again, today's homework is going to be a worksheet, you guys. We'll make sure to have the key up. And just let me know if you have any questions. Feel free to utilize the discussion board. Join me for my live sessions with algebra at 1 o'clock. But yeah, again, keep providing feedback as far as things go. Use the discussion board and join me for those live sessions and let me know if you have questions.